And okay, can you see my screen now?
Yes.
Okay, sounds good. Okay, so in the lecture today, I will give you a very brief overview about the pavement, a general concept about the pavement, and also some definitions, fundamental definitions about the different type of the pavement. Here we have the actually in the lecture yesterday, we have some introductions about the pavement. We say that pavement is some of the simple engineering problem, and also we have the video to. I intend to show you the video, but it doesn't work at that time. So I think I can play it for now, so you can go to watch the video. And this video will show you the procedures for you to complete the pavement. And let me know if you have any difficulty with the page.
Hi, this is Paul Del Rio with Packy. You know, much more goes into building a road than just paving that surface that we drive on. There are long periods of planning and preparation that take place before even a single scoop of soil is moved. And when physical construction begins, there are things that go under the roadway that provide strength, structure, and drainage. Here's how it works. Once the location of the roadway has been established, the first step is to evaluate the topography to determine the quality and strength of the existing material and how much soil will need to be removed or added. Before the construction process begins, the designer will consider potential impacts on the traffic system as well as the environment. This helps determine the best design for that particular location, such as the number of lanes and the path the road takes, as well as the thickness of the pavement itself. Once the engineers and the developer have chosen a design solution, the contractor can begin work. The site will need to be cleared of debris or vegetation. Depending on the topography, there will be a certain amount of both cut and fill on the project, or soil areas that need to be lowered or raised in elevation. The soil must be compacted in order to reach the proper strength to support the weight of the roadway and traffic. A grader machine is used to achieve the final grade or slope of the roadway subbase. Underlying electrical and water utilities and drainage are also constructed before the pavement is laid down. Stormwater pipes are installed along the length of the roadway according to the design. These pipes collect water from catch basins placed along the gutter. The storm pipes then feed into a larger system or possibly a detention pond. Roadways without a curb and gutter system may have ditches beside the shoulder, which also assist in transferring storm water. With the utilities installed and the soil at the proper grade, the contractor can begin on the roadway structure. This typically starts with a stone aggregate base. The base may vary in size and thickness depending upon traffic and drainage conditions. Asphalt is then paved onto the aggregate base by a paving train. The pavement can be applied in a number of layers and mixed types. Once the asphalt is compacted and cooled, it's time to paint the lane stripes and install reflectors, roadway signs, and possibly guardrails. After the contractor removes any equipment and cleans the site, the new roadway is opened for business. Proper maintenance of the asphalt pavement and drainage structures following construction ensures a safe and smooth roadway for years to come.
Okay, in the video, you might get some of the keywords for the pavement, like the selection of the geometry of the road, the earthwork, how to remove the soils, and also the design about the pavement, and also you have the drainages, the climate control, and we also need to think about the maintenance that we need to help to support the pavement for a longer time. So if we just watch the video, you can see that the construction of the road is very simple. Just some of the laying some of the materials and compact them and put some of the asphalt materials and paint the surface of the road. But if we go to the design about the whole road, the preparation of the pavement is very complicated, and there will be a lot of things that we have to consider. As I showed in the last lecture, we have to consider the materials, the traffic conditions, the environmental impact, and the maintenance and sustainability of this system. So in this overview, I will just give you some basic concepts in the pavement design and the most common pavement types that we're going to use at different places of the world and also in Ontario. So for the pavement, as we just explained, we have to consider the materials, traffic, and environment. Regarding to the material, we need to think about whether there's any available materials in the field. This will help us to reduce the cost of the transportation. And we also need to do some experiment about the behaviors of the material, such as the CBRs and resilient modulars and so on. And for the traffic, we have to consider what's the volume of the traffic for the road that it's designed for, and what's the magnitude of the traffic, whether there are a lot of heavy trucks and whether it's only designed for the passenger vehicles. And also we need to check the changes of the traffic condition on that road, how the traffic will increase over the year. And this will be applied for us to analyze the long-term impact or the long-term maintenance cost for the pavement. Also, for the construction of the pavement, the environmental impact is very important. Especially we need to think about the impact of the temperature. The high temperature will cause some of the expansion, and low temperature will make the materials shrink, and this will cause some of the distress to the road pavement. Similar effect can be observed for the moistures, freeze soil effect, and the local climate conditions. So the design in Ontario and even inside Ontario will be very different at different locations. For example, in Hamilton area, the impact about the freeze and soil effect will be very different from the one in Northern Ontario. And of course, it's very different from United States. We also need to think about or do some analysis about the distress to the pavement, the different type of the distress and their potential causes of the distresses. Also, some distresses, some minor distresses may lead to some of the severe distresses to the road and significantly affect the performance of the pavement. And how this interaction will be generated for the pavement should be analyzed even before we do the construction. And then the rest will be the construction of the pavement. This will be the real field work. And we have to think about the cost of the maintenance and the frequency of the maintenance and the sustainability of the pavement to support the road traffic. And the life cycle cost analysis is also very important for us to control the budget and to make sure that the pavement can last as long as possible. So in general, for the pavement design, our purpose is like we want to provide a very strong and stiff pavement to support the designed vehicle load. And especially we want to think about the support for the truck traffic, because the load from the truck is much higher compared to than the passenger cars. And usually we will only need to think about the truck load and the truck volumes on the pavement on the road to complete the design. And we also want to design the pavement which are safe and is able to provide the smooth and comfortable ride. And the surface of the pavement should be smooth enough, and the curvatures should be comfortable for the drivers to take. And also, we want this pavement to last for a longer time without causing any functional failure, which means that the if there's any functional failure, means that the road will be less smooth and it will be disturbed a lot and make the drivers uncomfortable driving on the road. And of course, the budget is a very significant factor. For the pavement construction, we have to consider the initial construction cost, which would be the cost for you to develop a new road, and the maintenance cost. This is what happens periodically during the design life. And we need to think about the life cycle cost, the cost for the whole design period. And the sustainability, like whether it can always provide satisfactory performance for all the users, and it can last for a longer time, and we can also reuse all the materials for the pavement. Regarding to the types of the pavement, for now there are actually they can be categorized into 5 types. The first one is called the flexible pavement, where it will apply the asphalt concrete as the surface. The second one is the rigid pavement, which will use the Portland cement concrete, PCC, as the surface. These two are the most common pavement in Canada and the US. For the third one, the composite pavement, it will use both the asphalt layer and the Portland cement concrete for the to construct the surface of the pavement, and then apply some of the stabilized base and sub-base layers. Usually they will put the asphalt concrete on top of the Portland cement concrete. For the composite pavement, it's applied a lot in Europe, but not in US and Canada. Also, we have the interlocking brick pavement. This is usually applied for some driveways and some place which is only designed for the pedestrians. And for the rest, that will be the unpaved road. First, for the composite pavement, which we will also call as the PCC sandwich. And as I mentioned previously, this one applied in Europe a lot, like in Germany, Austria, and some of the other countries. But they were not frequently applied in US and Canada. Usually for this type of the pavement, we will put 2 layers. On top of it, we will have the very high quality aggregate concrete, and the thickness of this one is relatively low, but it will be placed on top of low quality local aggregate or recycled concrete. The thickness of that one, of the lower layer, is very high. So these 2 layers will be combined together to protect each other. However, there will be some issues for the composite pavement. The most critical issue is like for this kind of the pavement, we can observe the reflection cracking, which means that usually for the PCC layer, we will have the PCC slabs. And you will know that because there will be slabs, they will be put together, and there will be some gaps between 2 slabs. But for the asphalt concrete layer, we do not have any gap at the initial construction. But this gap at the lower layer, the PCC layer, will not be strong enough to support the load from the top. And this kind of gap will be reflected to the top of the asphalt layer. And with that, you can see there will be some of the rectangular crackings or the square crackings on the surface of the pavement. And this type of the cracking is just defined as the reflection cracking, and it happens a lot for the composite pavements. And regarding to the pavements applied in Ontario, we have several types of the pavement. For the first three figure on the top shows the flexible pavement, and we have the conventional pavement and full depth pavement. Usually for the conventional, actually for the conventional pavement, we will have the asphalt surface and the asphalt binder. Both of them will be defined as the asphalt concrete layer. And then behind it, we will have the granular base layer and the granular subbase layer. And at the bottom, that will be the subgrade. Subgrade is actually the nature soil, but we apply some of the compaction to the nature soil and put all the layers on top. First, we will have the subbase, and then we have the base and the asphalt binder and the asphalt surface. Well, this one is good for the area with a strong subgrade soil, but for the region with poor aggregates, poor natural aggregates, we may need to use the full depth design. For the full depth pavement, we will have the asphalt surface and asphalt binder, but their thickness is much higher than the conventional pavement. Well, here you can see that for the conventional pavement, usually it's only around 120 millimeters, but for the full depth, it could be approximately 300 millimeters, and for this case, it's 290 millimeters. And in between, that will be in the deep strength pavement. For the deep strength pavement, it will still have the very thick asphalt surface and asphalt binder. Of course, it's a little bit thinner compared to the full depth. But different from the full depth pavement, it will also have the granular base layer. So this would be the granular base layer. The granular base layer can support the top two layers, the asphalt surface and the binder layers. So that's the design for the flexible pavement. And this is just a very brief introduction about the flexible pavement. In the future, we will have more detailed introduction about how we're going to select the materials for each layer and how we can design the thickness for each layer. In Ontario, we also have the rigid pavements, and the rigid pavements is at most of the roads we will apply the plain rigid pavements, where we will only have the PCC slabs applied on top of the subbase layer. And so there will be only two layers. There will be some of the rare case will apply the composite design. So we will have the PCC layer in the middle, and on top of the PCC layer we have the asphalt surface. Also at the bottom we will have the subbase layer, and all of them will actually be placed on top of the subgrade. So this would be the common type of the pavement applied in Ontario roads. The things that we want to check or we care about is the flexible pavement and rigid pavement. So we will first go to see some of the fundamental concepts that are going to use for the flexible pavement. The flexible pavement we will introduce in this class is also in a layered system, which means that it will apply different layers for the pavement. So the figure here shows the flexible pavement with the layered system. So you can see that usually there will be 4 layers, and the last one At the very bottom, we have the subgrade. This would be the foundation soil, and it's also the nature soil. So we will just do some earthwork to make the road smooth, and then do some compaction about those soils. And then on top of that, we will have the subbase. The subbase will have will also use the nature soil, which can be obtained from the local area. And we will do some compaction, and also we will try to process the gradation of these materials. And this will be placed just on top of the subgrade. And then on top of the subbase is the base layer. Usually we will apply some manufactured materials, and also the gradation of the aggregates for this layer, for the material in this layer, it should also be carefully selected. And on top, that will be the surface layer. We will have the asphalt concrete for the construction of the surface. Basically, you will see some of the unique features for each layer. For the first layer, the surface layer, it contains the asphalt concrete. It's very strong and it's durable, can support different type of the traffic load. And with that, it's able to last for a longer time. Also, it is impermeable to the waters, which means that it can resist the water to enter to the pavement structure. And of course, the manufactured material and is the most expensive material we have to use for the pavement. For the base layer, as we're gonna use the manufactured materials with a carefully selected gradation for the aggregates, and is also designed to help to remove the waters in the pavement structure, so that we will have less impact from the moisture or the water. And with the carefully selected manufactured materials, is able to provide a very, it's not less stronger compared to the surface, but it can also support very high load to the pavement. And compared to the asphalt material, it's less expensive. Usually we will use the so-called granular A aggregates for the base layer. And the thickness can vary from 150 to 500 millimeters, depending on the traffic load and the weather conditions. For the base layer, it's the nature material, so it's not expensive. You can obtain at some of the local companies, or just using some local materials and do some process about it. And also it can have the free draining property, which means that it's able to drain the water under the pavement and use the pipeline to remove all the waters there, so that we can minimize the impact of the moisture. And compared with the base layer, it has the moderate strength, which means that it can support less load. But as it's behind the base layer, so it's not necessary to for us to design very strong layer to support the load. And usually we'll use the granular B aggregates, and the thickness also varies around 150 to 500 millimeters. In the future lectures, we will give you some examples about the granular A and granular B materials, and you will see the gradation, which means that the percentage of the soils with a different size. And the last one is the subgrade. So this is the nature soil, and it's actually you cannot modify the property of these materials, and at most case it will be very sensitive to moisture. So this layer is relatively weak. If you apply a heavy load to this layer, you will see a very significant deformation for this layer. But we will have the 3 layers, subbase, base, and surface layer designed on top. So the top three layers can protect the subgrade. So that's the conventional flexible pavement structure. And here we will have some summaries about the each layer. For the base and sub-base layer, they have very similar purpose. They are designed to control the drainage to make sure that the water can be removed as quickly as possible from the pavement structure. And also they are designed to protect against the frost action or the volume changes due to the temperature. And also for the base layer, as it's also able to provide some support for the heavy loads. So during the reconstruction period or before we start the construction of the surface layer, they can support the traffic. So this is a very important layer. And the other purpose of this layer, the base and sub-base layers, so it can increase the structural capacity. This is one important concept for us to make sure that this pavement can last for a longer time. And we will have more detailed definition about the structure factor in the pavement design for the future lectures. And for the asphalt concrete or the Portland cement concrete, they were actually placed on top of the pavement, and they are very strong to support a very heavy load from the passenger cars and the trucks. Also, their surface will be processed to make it smooth and resist to the skid, so that the vehicles moving on the pavement on the surface of the pavement will be quite smooth, and there isn't any disturbance for the drivers or the passengers in those vehicles. And so the reason, there are actually many reasons for us to use the layered system. And I'm not quite sure whether you have learned the 2-to-1 rule in your previous class, but this one is also applied for us to analyze the distribution of the load at different depths of the pavement structure. So basically for the 2-to-1 rule, if we can find out a load to the surface of the pavement, say this is in the surface, and the 2-to-1 rule will indicate that the load will be transferred to the lower level of the pavement, and if the depth here, say that is Z1, then they will expand it to extend the boundaries to the area about Z1/2. So which means that if this coverage length is L, then the length, the load will be distributed under the depth of Z1 as L plus 2 times Z1 divided by 2, which that would be L plus Z1. Well, similarly, you can find out the distribution under the further depths. So for the depth of Z2, that will be L plus Z2, and Z3, that will be L plus Z3. And you can also see that with a longer, with a higher value of the depth, the distribution of the load will be flatter, which means, and also the absolute value will be smaller. So this indicates that in order to reduce the stress or the deformation or the strain caused by the surface load, we need to have some materials to support a very large load at the region which are close to the surface. But for the area which will be far away to the surface, the materials does not need to be that strong. as the load that it has to support is smaller. And for the location with very high depths, then probably don't need to have any manufactured materials. So you can just use the natural materials. This will be like the subgrade. That's the reason we're gonna do a simple compaction for the subgrade and put the pavement structures on top of it. So the so what we can see that the with the layer system, the stress will decrease with the depth, and we can use some materials on top of the pavement to protect the layers, the weaker layers at the bottom. And that's the purpose for us to introduce the layered system. And this figure actually shows the how the stiffness effect is applied for the layer system. And assuming that we only have two layers, layer 1 and layer 2. The value of E represents the modulus of elasticity. With a higher value of modulus of elasticity means that the layer is stiff enough, which can try to protect or support a higher load from the surface. And the figure here, the figure on the figure B actually shows the distribution or the values of the deformation, the stress under the vertical stress under different depths. Here you can see that if the depth is an edge, and if the ratio between E1 and E2 is 1, which means that these two layers have the same stiffness, then the vertical distress will reduce from only reduce from 1.0 to someplace around 0.65. But if you increase the ratio between E1 and E2 from 1 to 100, then the value will be reduced. I mean, the vertical stress can be reduced from 1.0 to some value around 0.1. And this means that you don't need to have, if the stiffness of the top layer is high enough, then you don't need to have very strong lower layers. And you can choose some cheap materials as the low layer, and this will provide the similar performance for the traffic on the road. So that's the layered system, and also for the flexible pavement design, as we mentioned, that there will be some of the conventional flexible pavement design, and the asphalt layer actually consists of two parts. It has the surface layer and the binder layer. There will be some minor difference about the surface layer, the material selected for the surface layer and the binder layer, and actually the major purpose for us to differentiate them is still based on the consideration of the budget and also the availability of the materials. So for the surface layer, for the surface layer we have the surface course, which is very thin, and it will make the surface smooth and skid resist, because this layer is directly contact with the tire of the vehicles, and we have to make sure that the pavement will be smooth for all the vehicles who is traveling on the road. And the binder layer will use the large aggregates, and it will be very strong. The stiffness is very high so that it can support to prevent the routing distress from the traffic load. But both of them will use the asphalt. Actually, they will use the asphalt concrete. They just have different type of the aggregates mixed with the asphalt. In that sense, they all called the layered the asphalt concrete layer, and we define this type of the design as the layered AC layer. For the full depth is a little bit different. For the full depth, we will have the asphalt surface, which would be around 50 to 100 millimeters. We also have another very thick asphalt base. Instead of just using the aggregates, we will use the asphalt concrete as the base layer. The depth is about 50 to 500 millimeters, depending on the requirement of the pavement in traffic and the climate conditions. And they will be placed directly on top of the subgrade, which will be the natural soil. This is usually applied at the region with a very poor natural aggregates. So we cannot do any further improvement about the natural soil. And then we need to rely on the pavement structure, which would be the asphalt surface and asphalt base. 100% rely on these two layers. And the other type of the pavement is called the long life asphalt pavement. This one is designed to last for a longer time to provide reliable services in 20, 30 years or even longer. So the figure here shows the structure of this type of the pavement. It has a durable top layer, which is also an asphalt concrete layer. And it has a very strong middle layer, and this layer is a rot resistance, so it will not cause any deformation when there's a heavy load. And at the bottom of the second layer, there will be a flexible bottom layer with very high fatigue resistance. So this one can help the pavement structure to support the repeated load of the traffic. Especially the truck traffic traveling on the road. And those three layers will be placed on top of the pavement foundations. It could be the granule base layer, sub-base layer, or the subgrade layer. And so these three parts would all be the asphalt concrete layers. And the thickness of these three layers varies based on the requirement of the pavement. So for more details, the first layer, the top layer, will have very high stress level, and with that it can provide any, it can resist to any potential crackings caused by the heavy load in the vertical direction and the horizontal direction. And for the middle layer, it's a rot resistance, and we have to choose the materials, rot resistant materials, based on the budget that we have, and also based on the design of the. For example, if we are using the super pave for the design of the second layer, then we need to carefully consider the aggregates of the materials. And similarly, we will have the consideration for the third layer. And usually for the second layer, the depth is for the first layer, the thickness is around 40 to 75 millimeters. And for the second layer, it should be long. The thickness should be designed based on the consideration of the traffic load. Basically, the traffic load will transfer to the thickness around 100 to 150 millimeters. So we have to make sure that the total length here from the surface layer, and the second layer should be larger than the value 100 to 150 millimeters. And for the third layer, usually it's around 75 to 100 millimeters. And so here is some summary about the long life asphalt pavement. So we have the thin pavement readily crack and rot under the repeated load of the heavy traffic. So all actually the surface layer can be removed if we find that it's not it cannot provide a reliable service to the road traffic. And in the thick asphalt pavement, it's actually we will have some of the potential fatigue cracking, and by increasing the thickness, we can reduce the fatigue cracking. And with that, we will make sure that the cracking will only, the pavement distress or the cracking will only occurs in the top layers. So if there's anything wrong or the service or the performance of the pavement is not good enough, we just need to remove the surface layer and put the new materials on top. And this kind of method can help us to reduce the cost to do the maintenance of the pavement. And another pavement that we're going to introduce is called the perpetual pavement. This is another type of the flexible pavement. It actually belongs to the long life pavement. It's one type of long life pavement, and this one is it's designed to last for a very long time, which means that it can provide reliable service for 50 years or even longer. And it does not need any frequent maintenance of the pavement. Approximately, we just need to maintain the road for every 20 years. And it can try to resist the structural failure and function failure. So with the design, we can minimize the crackings, the rottings or fatigue crackings from the traffic and also from the environment conditions. So there will be a little bit different or a little bit improvement from the long life pavement. For the perpetual pavement, you will also use the multi-AC layer design, and it has a renewable surface layer. So the surface layer will apply some of the renewable materials, and it have very strong rot resistant and durable intermediate layer, and a very flexible fatigue resistant bottom layer. And of course, with this kind of design, we can get a lot of advantages, like it can last for a longer time, it has less fatigue cracking, less rotting, and the surface will be very smooth, and we don't need any major reconstruction or the maintenance, and we will have less interruption to the road traffic, because at every time you do the maintenance, you have to close the road, and they have some huge disruption to the traffic. But it also has some disadvantages. The major disadvantages, like the cost, the initial construction cost is very high. Compared with the long life pavement, the thickness of the asphalt layer is much higher. It's usually around 250 to 350 millimeters. It's much thicker compared to the long life pavement. Actually for the conventional pavement, usually it's less than 150 meters. You can see the double or triple of the conventional design. So this is actually one example about the the perpetual pavement in Ontario. It's the perpetual pavement. This is actually the first example of the perpetual pavement in Ontario, which is applied in Highway 406, which this road is quite close to the Niagara Falls. Before 2007, Highway 406 is constructed with the conventional deep strength design. So it has the asphalt. It has the asphalt concrete layer with a thickness around 200 millimeters if you add all of them together. But in 2007, the government to do some reconstruction, redesigned the Highway 406 and applied the perpetual pavement design. And the thickness increased for the asphalt concrete layer increased from 200 millimeters to 250 millimeters. This is a very significant increase about the thickness and the budget, but based on the latest evaluation about the performance of the pavement, it has much less crackings and rotting on the roads, which means that the perpetual pavement is it actually can provide a very good performance for the road, and we don't need that. We don't need any significant budget to do the maintenance for the perpetual pavement. So I think that will be all about the lectures for the overview today. Do you have any questions? And okay, so in the next week we actually have some other type of the pavement we need to introduce in the next lecture, including the design of the rigid pavement and the interlock pavement and so on. Also, I plan to give you homework number 0, which would be the bonus points for your final grade. Basically, the homework will ask you to take some pictures about the pavement distress, some of the crackings and the failure examples on your road, and I would like to ask you to find out 5 typical failed pavement design, or the 5 typical crackings, and define them, or you need to identify them in real roads. There will be more details will be shown in the homework number 0. Okay. If you don't have any questions, I guess that will be all for the lecture today. And you feel free to send me email if you recall something about the lecture, or you have any concern about the this class. And remember, you need to finish this array as soon as possible, and we can then go to design the or assign the lab groups. Okay. Okay, that's all for the meeting today. Thank you very much for your attendance, and I will see you next week.